Okay, so let's talk about Lewis structures. So what a Lewis structure is it essentially represents how atoms are attached to each other. It's the skeleton structure of how atoms in compounds or molecules are attached. To each other. And it's basically the bonds between them. And it's based on valence electrons. So first maybe let's define what a valence electron is again. So a valence electron is the electrons in the outermost shell of an atom. So the valence, they're in the outermost shell. Sometimes they're called the valence shell. And these are the only electrons available to participate in chemical bonds. So the best way to teach about Lewis structures is to just do some. So let's do, the first one we're going to look at is ammonia. Ammonia is really nitrogen trihydride. Ammonia is the common name. I wouldn't expect you to know the common name. It's nitrogen trihydride, which is NH3. Do not get ammonia and ammonium confused. The ammonium ion is NH4 plus. And then NH3, nitrogen trihydride, the common name for that is ammonia. So this is a covalent molecule. It's covalent because nitrogen is a nonmetal, hydrogen is a nonmetal. And even though hydrogen is in this upper left-hand corner of the periodic table, remember, it is still a nonmetal. It doesn't really live anywhere. Anywhere you put it on the periodic table would be the wrong place for it. If you put it over here, it would be wrong. Over there, it's wrong. So that's just where it lives, and we know it's an exception. So it's nitrogen and hydrogen. Nitrogen trihydride. So it's nitrogen with 3 hydrogens. So what we need to do is, the first thing we need to do is we need to figure out how many valence electrons does nitrogen have and hydrogen have. Okay, so how many valence electrons does nitrogen have and how many valence electrons does hydrogen have? Okay, so nitrogen is in group 5. That tells you how many valence electrons it has. It has 5 valence electrons. And I'm going to draw this out for you. So nitrogen is number 7 on the periodic table. So nitrogen has a nucleus where the protons and the neutrons live. And then it has one shell. The first shell, remember, just has 2 electrons. It has room for 2 electrons. 1, 2. The next shell has room for 8 electrons, but nitrogen itself only has 7 total electrons. 7, 1, 2, 3, 4, 5, 6, 7. So remember we said the valence electrons are the electrons in the outermost shell. So only these electrons, 1, 2, 3, 4, 5. There are 5 valence electrons here. So even though nitrogen has 7 electrons total, it has 5 valence electrons. Only the electrons in the outermost shell are able to participate in chemical bonds. These 2 electrons are what's called shielded because they are not in the outermost shell. These 2 electrons cannot participate in any bonds. Only the bonds in the outermost shell, the valence electrons, are available to participate in chemical bonds, and that's what we need for the Lewis structure. So the valence electrons for nitrogen is 5. Hydrogen is number 1. Hydrogen just has 1 electron, and it just has 1 in its outermost shell. So it has 1 valence electron. So you want to see how many total valence electrons are there. But remember, we have 1 nitrogen, we have 3 hydrogens. So it's really 1 times 3. So total valence electrons are 8. So the first thing you want to see is how many total valence electrons are there. And then you are going to make a skeleton of how these nitrogens and hydrogens are arranged to distribute those electrons so that everybody has a full shell, and see what that shape looks like. So this is how we do it. You usually put what has what's called the highest bonding capacity in the middle. Hydrogen, so the bonding capacity is essentially the left out things to make up a full octet. So hydrogen would only have a bonding capacity of 1 because it only wants to make 1 bond, because it only needs 2 electrons to have a full outer shell. Nitrogen could make 3 bonds because it wants to have 8 electrons to have a full shell. We are sharing electrons. So a single bond is sharing 2 electrons. So let's just write this out, and then I'm going to work through it with you guys, okay? So here is the nitrogen. I'm going to put that in the middle because it has a higher bonding capacity, meaning it can make more bonds. And then I need to draw lines, which are single bonds, to everything else in there. So I have 3 hydrogens, and the positions that you put this are essentially arbitrary, but usually we make it in the shape of a square as much as we can. So here's my nitrogen, here's my 1, 2, 3 hydrogens. So you put the elements here, the one that has the highest bonding capacity goes in the middle, and then you put the other ones around it. Then you're going to draw lines that represent single bonds. Single bond is 1 line, which represents sharing 2 electrons. And then you are going to fill in the rest of the valence electrons until everybody has a full outer shell. So we're going to draw single bonds to all the elements. Then we're going to fill in remaining valence electrons until all elements have a full outer shell. Which, remember, an outer shell for hydrogen is just 2 electrons. Hydrogen just wants 2 electrons to be full, just hydrogen and helium. Everything else, a full outer shell, is an octet, 8 electrons. So hydrogen just wants 2 electrons. So these 3 hydrogens all have a single bond. They all are sharing 2 electrons. These 3 hydrogens all have full octets. So we don't need any more electrons for them. Nitrogen wants 8. And remember we said each of these single bonds is sharing 2. So 2, 4, 6, and I have 8 total, which means these last 2 are going to go right here. So this is the correct Lewis structure for ammonia, where we have nitrogen singly bonded to these 3 hydrogens, and then the remaining 2 valence electrons go back on the nitrogen. So nitrogen has 2, 4, 6, 8 electrons around it, and hydrogen has 2, 4, 6. So each of these single bonds equals a shared pair of electrons. So another way that we could write this, I won't write it this way because the textbook doesn't do this way, but instead of showing a bond, I could show a pair. So this is not the way I will do it, but you could show it like this. And this shows those 8 electrons. But instead of having a shared pair of electrons between two atoms, we show it as a line representing a single bond. So these are essentially the same, but this is not the way that I will show Lewis structures because this is not the way that your textbook does it. Okay, so we will do a lot of practice with these. We need to have a really good handle on Lewis structures because everything that we're going to do in chapters 5 and 6 is dependent on having a correct Lewis structure. If the Lewis structure is wrong, the rest of the problem will be wrong. So we're going to spend a lot of time practicing Lewis structures. So let's look at another one. So let's look at something called carbon tetrachloride. So on an exam, you might see me write the Lewis structure for carbon tetrachloride. So the first thing you would need to do from the name is you would need to write the formula. So carbon and chlorine are both nonmetals. Carbon is a nonmetal, chlorine is a nonmetal. So carbon tetrachloride, Cl4. So CCl4 is the formula for carbon tetrachloride. So what we're going to do is we're going to see how many total valence electrons do we have. So I have carbon, and then I have chlorine, and that number is going to be times 4 because I have 4 of them. Okay, so here's carbon. Carbon is in group 4, which means it has 4 valence electrons. Chlorine is in group 7, which means chlorine has 7 valence electrons. So the total valence electrons, 4 plus 7 times 4, which is 28. So 28 plus 4 is 32. So I have 32 valence electrons to distribute. So what I'm going to do is I'm going to write the skeleton. Another thing to keep in mind is that these molecules or compounds always want to be as symmetrical as possible. So if you have 4 of something, most likely you're going to put the other one in the middle and put the 4 things around it. But the other way to know is that because carbon has 4 valence electrons, it can make 4 bonds. Chlorine has 7 valence electrons, so it only wants to make 1 bond. So chlorine has a lower bonding capacity. Carbon has a higher bonding capacity. Carbon is what's going to go in the middle. So I'm just going to go like this. Carbon. I'll put the chlorines around the carbon. So now the next thing you do is you're going to draw a single bond to all the elements. And then you're going to fill in the remaining valence electrons until all the elements have full outer shells. So right here, just drawing the lines, the bonds from the central atom to the outside atoms, I've used up 2, 4, 6, 8 of my total 32 electrons. So now I have 24 left because I've used up 8. 2, 4, 6, 8. Carbon is full because remember each of these bonds is sharing 2 electrons. So there's 8 electrons around this carbon. So carbon is happy. I don't need to add any more electrons to carbon. Each of these chlorines only has 2 electrons. So each of these chlorines is going to want 6 more electrons. So let's count the electrons. So I have 32. I've used 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So, sorry, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So now I've distributed all of the valence electrons. There's 8 of the electrons that are bonding the carbon to the chlorine, and the other 24 electrons went around those chlorines. So this is the correct Lewis structure. Because everybody has a full outer shell, a full octet is the lowest energy, it's the most stable, it's what these bonds are forming for to have the lowest energy, the most stable arrangement. So carbon tetrachloride. So there were 32 valence electrons, we put the one with the highest bonding capacity in the middle, put the bonds from the central atom to the outer atoms, and then filled in the valence electrons for everything else. So that was carbon tetrachloride. So I will post another video with some more examples.